I have the great pleasure of hosting Professor Michael Littman. So, Professor Littman, thank you so much for your time and for doing this podcast.
It's my pleasure. Thanks for reaching out.
Wonderful. Okay, so I would like to start our discussion with questions on AI and reinforcement learning. But before we start, may I ask you what first sparked your interest in CS and AI in general?
Yeah. So when I was a teenager, computers were first starting to become available as things you could buy for your home. And I discovered one in a shopping mall, and I just thought it was the coolest thing ever. I would try to stump it by asking it difficult problems like, what is one plus one? But wait, what is one plus one plus one? And it always got the right answer. And I was like, how is it knowing that? How does it know all the things I could ask? And I just found that fascinating. So I talked my parents into getting me a computer, and I spent the next couple of years just teaching myself everything I could possibly. And by the time I graduated high school, I was excited to embark on computing as a career.
Wonderful. So, can you share a specific moment in your career that basically influenced your focus on reinforcement learning?
Yeah, I mean, to me, it's always been about getting computers to do interesting things. And to I found, I guess, let's see. So I was in college. I was studying some artificial intelligence and computer science more generally, and I just thought it would be really neat if a program could beat me in tic tac toe. Right, that was a game that I knew required a little bit of thought, but didn't seem that complicated. And so I ended up spending an entire I think it was like Thanksgiving break. I went home, and instead of interacting with my family, which I understand you're supposed to do, and now as a parent, I think I'd be heartbroken if my kids had done this to me. But I closed the door, I put myself in my room, and I just coded for a week straight until I had a program that could actually learn to play tic tac toe just from experience, just from interacting with itself. And I learned a ton from that about about programming, but also about ways that learning can go wrong, especially when you're playing against yourself. And I think that those are lessons that actually have been really valuable to me in as a participant in the research community around those kinds of questions about machines that just not don't just learn, but they actually learn from each other. And there's some subtleties there that make it really interesting.
Can you just say how much has the field of reinforcement learning evolved since you first started working on it?
Yeah, so after college, I joined a research group at what was called Bell Communications Research, or Bellcore. It had spun out of the Bell Labs community, and I was working very closely with a researcher by the name of David Ackley, who, by the way, was first author of the Boltzmann machine paper that was just highlighted in terms of winning the or providing fodder for the giving of the Nobel Prize in Physics. So he wasn't given the Nobel Prize in Physics, but one of the other authors of that was specifically Jeff Hinton. And so, but I got to work with Dave Ackley, and it was fantastic. And I told them that I was really interested in learning, and specifically learning from evaluative feedback. That's not the word that I used at the time, but kind of learning from your own mistakes, right? I think what was popular then and continues to be extremely powerful and popular now is supervised learning, where you take a data set of this is how you should behave, this is the thing you should do. And I just thought so much of learning, especially for things like tic tac toe, I didn't know what to tell the tic tac toe playing program. I just knew when it won or lost, and I wanted it to figure out how to behave. So I described all this to him, and he listened, and he said, "Yeah, there's a name for that. It's called reinforcement learning, and there's a relatively recent paper that came out by this guy, Rich Sutton. Why don't we invite him to come give a talk?" I was like, "Wait, you can do that? Like, you can actually uh, read about somebody's work in a paper and then have that person come and talk to you about it?" And so, yeah, we invited Rich Sutton, and I learned a lot about what the field looked like at that time, and then I got to be a contributor really in the 90s to the way that the field was taking shape. You asked about ways that the field has changed, and obviously the biggest update has been because of deep learning. The things that we knew how to do actually back then in the late 80s, early 90s, but didn't really work, right? So we knew that a neural network would be useful in the context of reinforcement learning, and we knew what the update rules in reinforcement learning needed to look like. But training those networks, they were just very brittle and they tended not to work well. And so uh, Jerry Tesaro, sorry, I was blanked on his name for a second. I think the Jeff Hinton threw me off. Jerry Tesaro was sort of a magician with this sort of thing, and he could get reinforcement learners to work with neural networks. But back then, basically everybody else just failed. I had a bunch of students who wanted to work on that. We all tried it. It never worked. And it's like, of course it's never going to work. This is just a flawed idea. We just need something else. And we kind of put it on the shelf for a while. But then after deep learning came about and it was became possible to train these networks much more consistently and reliably, people revisited that question, and that sort of blew open the doors of the area that we now call deep reinforcement learning, and that has changed the character of the field a lot, I'd say.
Right. And what would you say are some of the most exciting current applications of reinforcement learning?
Yeah. No, yeah, I was recently compiling a list because I was trying to impress someone with just how important this technology is and how relevant it is in ways that they didn't even realize. Folks are using it, of course, for things like playing games, just like my tic-tac-toe playing program back from the '80s. But really going beyond that and saying, well, you can think of lots of decision making and optimization problems in this framework. What about things like supply chain optimization? So you're some large internet company that has to get actual physical items from warehouses to people's homes efficiently and in a timely fashion. There's tons of decisions that are being made throughout that whole system. Reinforcement learning is now starting to be used as a way of making those decisions more efficient and more data grounded. That's pretty exciting. There's some things that I think are very promising and impressive, but maybe not that practical yet. Things like the use of reinforcement learning in the context of solving cutting edge mathematics problems, right? So at the level of uh, high level competitions in mathematics, where these programs are actually able to very quickly teach themselves how to think about a particular kind of problem and then offer new solutions. That's really neat. Not because we really needed those problems solved, because the people who invented the problems actually knew the solution already, and they were just using it as a way to tell which students were the best at solving those kinds of problems. But it shows that there's kind of a pathway to doing some really new, groundbreaking reasoning that combines, again, the power of these deep networks with the ideas from reinforcement learning that are grounded in decision making and goal oriented behavior.
Do you think that large language models will put reinforcement learning aside?
I really don't. I think large language models in particular are amazing and fascinating, but they're no substitute for real decision making, right? So what these models are doing, at least to a first approximation, maybe second and third approximation, is imitating patterns of use of word usage that are visible in human writing. And it's shocking. Like, people talked about this for decades, that this, in principle, if you have a system that's really good at guessing the next word, it can actually create coherent dialogue. And but we never saw anything like that until very recently. So it seemed more like a theoretical possibility than something that would really happen. But now it's really happening, and that's amazing. But again, they're just imitating the patterns of word usage that people have demonstrated. And so really getting them to solve a problem and to be goal oriented is a harder problem and is a different problem. And in fact, if you look at some of the output of some of these language models, so for a while, I was tracking anytime a New York Times article talked about chatbots, language models, and the amazing things that they could do, they would always interview an expert. So it could translate languages. So they'd bring in a professional language translator and say, "What do you think about this?" And they would say, "That is amazing, but it lacks soul. Like, there's something missing from the output that makes it really less than, like, not as good as what a person like the best people would do. Extremely competent, but not all the way there." Same thing in music, same thing in designing new recipes, same thing in producing artwork. There's just something missing. And from my perspective, the thing that's missing is reinforcement learning. It's the idea that the system needs to be able to reason about what it's trying to accomplish, and the impact that the output that it produces will have on some other listener. And I don't think that language models alone get us there. We really need a combination of that sort of idea with something much more like goal-oriented behavior, something that we study in reinforcement learning.
Would you say that in order to achieve AGI or artificial general intelligence, the best way to pursue that path would be to use reinforcement learning instead of supervised learning?
I would. I think that supervised learning obviously has a role to play, especially in this sort of self-supervised context, the way that it's done for large language models. You want to make use of all the data that you've got, and capturing patterns in the data that could be useful for decision making is really important. And so I think that there's an ingredient in these language models and the studies people do around them that is absolutely critical, but it's just an ingredient and it's not even necessarily the main ingredient. I think that things around decision making really are the main thing that make, like, that's what intelligence looks like to us. It's about achieving something. And I don't think these language models really have internalized that. I don't think they can really internalize that idea.
Can you talk about the Humanity-Centered Robotics Initiative at Brown University and what it aims to achieve in the future?
Yeah, I it's it's um it's a little bit winding down. There's still a lot of really amazing work going on at Brown that's connected to it in one way or another. But originally, the way we envisioned it was as an opportunity to catalyze on campus efforts that people were doing to create new robot capabilities. And we really wanted to focus on ways that those robotic capabilities could have a beneficial impact on society at large, right? On humanity generally. And so that was the envisioned initiative that we started with, and we got some relatively good support from the university to do this. We generated some really fun and interesting results, but it never quite caught fire. Certainly, the way that the AI is catching fire right now. I could mention, and this is quite hot off the press, that Brown University decided to create a new initiative in AI that was announced this morning at 9 a.m. Specifically, they named an inaugural associate provost for artificial intelligence, whose job it would be to coordinate AI efforts across the university. And that would be me. And so this is a job that I'll be taking on sometime this.
Congratulations.
Thank you very much. Yeah, it's kind of exciting. And I think what's fun about it is the way that the university is looking at AI both as something that's important to support from a research perspective, that there's a lot we can offer in terms of generating new ideas, but also just the way that it's impacting life on campus more generally. And there's just this great opportunity to try to coordinate those efforts and to take the best ideas from all across campus and make sure that those get shared and implemented.
How can we design AI systems that are more aligned with human values?
Yeah, right. So this is obviously a topic that a lot of people have been talking about in the last couple of years. It sometimes goes by the term alignment. Alignment gets used in several different senses. I personally am most resonant with the notion that alignment it's a fancy word that just means computers should do what we want them to do. And so that's how I view it. And I think from that perspective, it's obviously an important topic. It's been the main topic ever since we've had computers, is we want them to do what we want them to do. And in fact, I wrote a book that came out a year ago that's called Code to Joy: Why Everyone Should Learn a Little Programming. That's very much about the idea of how do we tell computers what it is that we want them to do, and how can we be as successful as possible at that, right? And I think one of the things that the topic of alignment really highlights in a way that I think is quite beneficial is the tension between having to spell out every last little step that you want the computer to carry out, which will be accurate, but also grueling, right? It's just too hard, especially when we're asking computers to do really complicated tasks. Having to say every little possible contingency and how it should handle them is unworkable. So on the one side, it's just a lot of work to tell computers what to do. On the other side is that if you don't tell them what to do, or if you're not complete about the descriptions, the computer might fill in the missing pieces with stuff that is not at all what you wanted, and you could say not at all aligned with our values. But more concretely, it's just not what was intended, right? We want computers to do what we mean them to do, and if it does something different than that, that's bad. So that I think it's always been a challenge in computing, but I think now that these AI systems are getting to the point where they can fill in the gaps, now we really have to pay attention to the fact that they need to fill in the gaps the way we want them to fill in the gaps. And I mean, it raises all kinds of really fascinating philosophical issues. How do we manage this with other people, right? Is if there's not enough information in our instructions, in what we're conveying to each other, how does this not happen all the time where people just misinterpret or misunderstand and then essentially go off the rails? Um, and the fact is, we do a lot of the time, but we have one of the tools we have at our disposal is that when we tell each other what to do, when we're conveying a task to another person, we tend to use as many modalities as we possibly can. So we'll describe in words what we want to happen. So we'll kind of give instructions, but we'll also say, and this is what we're trying to accomplish. Because sometimes when you're executing the instructions and things go off the rails, you can catch it when you know, wait, this isn't actually heading towards the goal that I need to be heading to. You also use examples, like supervised learning sort of examples, where you say, and for example, if I were to say this, then you should respond this way. And all of these different mechanisms all come together to give a more complete picture, a more accurate picture of what it is that's desired. And of course, the word alignment also implies, and as you mentioned, human values, that there's in some ways, culturally common ideas that we have about things that are wrong, things that are inappropriate, that we don't have to spell out every time we talk to someone. Like, hey, I would like you to go over and tell this person this thing. We don't have to say without insulting them or without questioning their parentage. Like there's things that we just know because that's just expected in our society. And so that's another mechanism that we use when we use as people when we're conveying tasks to other people. We don't have to say everything because we can make assumptions about the kind of entity that we're talking to. They're like us and they're part of the same community as us. And so we can use all those same mechanisms to convey tasks to computers as well. It's just that nobody's really provided us with an integrated system that lets you poke at it from all these different angles and convey a task that way. But I think that's something that we should be pushing toward.
Your book called Code to Joy, which I highly recommend to our audience, basically encourages people to learn programming. So, why do you think that programming is important for everyone?
Yeah, that's a really great point. So people have been making those claims, I think, for 40, almost 50 years now about how, oh, we should all make sure that we teach kids to program. And I I try in the book to convey this sort of notion that I'm not talking about turning everybody into software engineers. Like we have professional software engineers, they're very good at what they do. Some people reading the book maybe would want to do that for a career, but I'm definitely not making the argument that everybody should be software engineers. But we do want to make use of computers, right? They're very empowering. They can help take some of the tasks that we have to do, especially tedious tasks, and help us just get them done. But the only way we can make use of them is if we have a mechanism for telling them what to do. And at the moment, programming is the best model for that, but by no means is it the only way. And so in each chapter in the book, I talk about a mechanism that we use in traditional programming, but then highlight some idea from machine learning and artificial intelligence that can help make that easier, that the computers can kind of meet us halfway or meet us partway. And we don't have to specify all the grimy, grungy details to get to build the kinds of systems that we want, to get computers to execute the kind of behaviors that we want. So for me, the emphasis is not so much on turning everybody into programmers, but on helping to make a more healthy relationship between people and their computers. People should view computers as a tool that can help them get their work done more efficiently. And I think ideas from programming and certainly having an open mind towards conveying more complicated tasks is a great way to do that.
I see. And how has your role at National Science Foundation shaped your views on AI research and AI policy in general?
Yeah, so I've been at the National Science Foundation for about 2.5 years now, almost 2.5 years, and I'll be heading back to Brown for the new position that I mentioned to you before in about 6 months. I it I was at the National Science Foundation during a very exciting period for artificial intelligence, right? So ChatGPT came out about 2 years ago, within my first year of being at NSF, and just the repercussions of that have been really astounding. throughout society, right? I mean, there was a period of time that I would be in an Uber or a Lyft. I'd be going from one place to another, and the driver would spontaneously just start talking to me about AI, not knowing that like this is my life, this is my job, this is what I've been doing for decades. But just because it's top of everyone's mind at the moment, and so that's been a very exciting thing. So I don't know. I don't know that I would say that NSF has changed my views on AI. I mean, it surely has, but it's also been such a weird, fascinating period of history that my ideas around AI were going to change no matter what. I certainly feel, as a result of being at NSF, much more, I guess, community oriented in a way that to me, it's not about what can I do personally to kind of make the breakthrough that's going to make everybody's lives better, but how can I support the community that's doing this? We have it takes a village, it takes a whole group of people working together to really make things better. And what how can I make sure that everyone else is has the they're enabled, they're kind of empowered to do the things that they're best at. And that's a nice way of looking at things. It's less I don't know, selfish. I don't want to say selfish, but less self-oriented and more kind of community oriented. And being at NSF surrounded by folks who dedicate their lives to that, it's very inspiring.
Yeah, that's truly wonderful. And what are some ethical considerations you think that AI society should prioritize right now?
Yeah, I think a lot of the things that we've been calling ethics in the last few years in terms of AI are really in some ways common sense that we just haven't wrapped our heads around yet, right? And so I think the biggest issue has been, do not deploy systems that impact people's lives without really carefully thinking through what those impacts might be and trying to put up the right kind of protections so that the even unanticipated consequences, negative consequences, are minimized as much as possible, right? Like, of course, right? Like, we don't tend to talk about ethical bridge building, but people who build bridges have to think about, okay, well, what's this going to do, and how is it going to be safe? How is it going to how are we going to make sure that there's equitable access to it, so that not only certain people from certain walks of life are going to have access. So I think a lot of the things that has gone under the term ethics has been in that space. Of course, there's a sort of deep, as I mentioned before, deep philosophical issues that come up when you're talking about highly powerful AI systems, and that's super fun, and it's intellectually fascinating to kind of dig into them. But the first order of business has got to be, let's get these systems out there helping people, and let's think about the negative consequences and try to minimize them. And of course, right? Of course, like we in AI always thought that our tools that we were producing would have a big impact on the world, but they hadn't for most of the history of the field, and now they are. And that's great, and like, we can pat ourselves on the back in various ways, but it means that we now have responsibility for making sure that the kinds of systems that we're building are being built in a way that doesn't have these sort of bad outcomes. And so that to me, I think, has become more central to the field than it had been in prior years, just because the systems that we're putting together, there's such a thin wall, right, between a researcher just throwing some code together and then suddenly it's actually out in the world and hundreds of thousands of people are impacted by it. That's something we have to be really thoughtful about.
Right. And to get back to reinforcement learning, can you explain the relationship between reinforcement learning and human decision making processes?
Sure, I think this is something that is not as well understood as it could be. But what reinforcement learning is, or at least so the term reinforcement learning dates way back to at least the 1930s, and psychologists were thinking about just trying to understand better, how do animals work? How do they change their behavior over time? Like, if we stimulate them in certain ways, their behavior changes. What are the rules of that? And they were thinking very much almost like physicists, right? Like, what are Newton's laws of animals and how they change their behavior? And so this entire field of animal learning came about, and one of the core concepts there was the notion that when you did certain things to animals at certain times, it tended to make the behavior that they were just doing stronger. So it reinforced that behavior. It made it stronger. And that seemed to be a really critical component to how animal behavior was changing when they had certain kinds of stimuli, like a drop of food after it executed some kind of action in the world, some sort of behavior in the world, they tended to do more of that action in the future. And so that notion of reinforcing of behavior became a really central concept in understanding animals. I want to say that in the 1980s, computer scientists were really interested in this as well, because we um, wanted to build computer programs that could be as adaptive and capable as animals or people. And so we turned to this was a little before my time, but my community turned to animals as a possible model. Okay, well, how do animals change their behavior? Oh, with this reinforcement learning thing. What does that mean? Well, I don't really understand what it means, but maybe it means maximizing reward. And so we kind of misunderstood the central concept of reinforcement learning in animals and viewed it differently. We viewed it as a kind of optimization process. So as opposed to just making behavior, you did a random behavior and then it becomes more strong. It's now no. There's values. There's things like juice is good. Money is good. Things are good. And what we're trying to do is select behaviors to maximize the chance of good things happening. But that is a misunderstanding of the term reinforcement learning. Nonetheless, it was extremely successful misunderstanding, because it turns out that not only does that allow you to build computer systems that can generate their own highly complex behavior, but psychologists looked at what the computer scientists were doing and applied it to analyze some of the animal learning, especially at the neuroscience level, that they were looking at, and they said, "Oh, with that, it finally makes sense now." So they actually took our misused term and readopted it back into animal learning, and is now a really central concept again in understanding how humans and animals behave, especially in terms of addictive behavior, lots of things like that. The whole dopamine system in the brain turns out to be a really good fit for the mathematical rule that computer scientists work on. So that's interesting.
What are some of the key challenges in creating artificial intelligence systems that can understand and adapt to complex human environments?
Yeah, I think we do not have the recipe for this yet, right? So as wonderful and as powerful as chatbots are, to get them going, we have to feed them with the equivalent of like hundreds of human beings' lifetimes worth of experience. And that's great for something like text, where you can just collect it and it's sort of static. But the essence of reinforcement learning is often around the idea of you have to do it, you have to try it, you have to observe the impact of your decisions. And there's lots of evidence, both from computer science and from animal psychology and human psychology, cognitive science, that has shown that it's through interactions with a complex environment that you really learn how to behave in that environment, how to accomplish tasks in that environment. And so that's hard, because this mechanism that we've really kind of been trying to wrap our heads around for the last 5-10 years doesn't really apply so well to this case of acting in the world, because you can't gather lots and lots and lots of static data and analyze the heck out of it for 30 days and generate a control policy. You have to be out there doing things. And that means learning a lot more from each little bit of experience than you have to if you've got a trillion words of text. And so I think that's remains a challenge. I haven't heard any ideas that really kind of get around that.
Right, and how do you see the intersection of artificial intelligence and education in the coming years?
Yeah, well, I mean, I guess I'm an optimistic person. I hope that it's a positive. I can always imagine ways that it can go off the rails, but the way that the positive story that as I see it is, look. So how do people, like actual real people, learn to be good at things? Part of it involves getting the right kind of feedback at the right kind of time, which of course is a reinforcement learning concept, but it's just true in teaching, right? This is why teachers are in the we don't just sit students in front of a TV and just have them watch movies of facts. It's about that interaction actually turns out to be really important, again, because people, to actually act in the world and handle complex environments, they have an idea of what might work, but the only way to find out if it actually works is to put it out and then to get to find out whether or not it was correct. And so that kind of feedback could be really valuably provided by AI systems, right? There could be AI systems that actually are there engaging with you, look, observing the different things that you're trying. If you're trying to learn how to, I don't know, do differential calculus or something like that, you can be trying things out and you can right away get like human tutor level feedback about what you're doing and how it's working. So I see that as a huge positive. I also, though, I think the history of research and education has shown that there is no substitute, or there's been no substitute identified for an inspiring teacher. And I think part of what makes a teacher inspiring is it's a person that you feel a connection to, and it's a meaningful human connection. And I don't think that we can just unplug all the people and just plug in these AI systems and expect human beings to have the motivation that they need to learn. If learning was just learning facts, sure, but it's not. It's actually part of it is learning how to be a person, and learning that from a non-person. I don't think that's a very promising direction. So what we really want to be doing is finding ways of taking the human connection that we've got and amplifying it or supplementing it so that people can do the things that people are good at, and the sort of high touch feedback that's just about repetition and understanding of a particular narrow range, we can outsource that to the computers. But finding the way of actually creating that team, that educational team, is, I think, a real challenge for the next decade or so.
And what would you say are the main lessons you have learned from working on probabilistic planning and decision making?
Be humble. I feel like that's the best lesson I've ever learned about anything. Um, one of the nice things about studying decision making under uncertainty is that sometimes you can do the right answer and the wrong thing happens. And understanding that that is just built into the world that we live in, and it's not like everything that looks like a mistake was a mistake and you need to change your behavior. That's a really powerful idea that I think we can all, if we all internalize that a little bit better, we'll all be nicer people and easier on ourselves and easier on the people around us, because I just think it's really important. So that's one lesson that I've learned, at least applied to human relationships.
Wonderful. And how do you think artificial intelligence will be can be used to enhance human creativity rather than replace it?
Yeah, I mean, I think we're seeing all kinds of amazing things lately where these systems, uh, they look really creative, right? Systems that generative AI systems that are producing images and songs, music, full orchestrations of things, text and poems and screenplays and so forth. They can actually be surprising and really interesting. But again, as I was mentioning before, I think the outputs of these systems tend to lack a certain, like, what was the point of that? What is it you're trying to convey? And I think that has to come from people. And so to the extent that we can make it easier for people to work with these systems, so that the human's vision, the thing that the human really wants to realize, can be creatively rendered through these tools. That's going to be really exciting, right? Really interesting. We're going to unlock another level of storytellers, people who had the great ideas but just didn't, they weren't great at visual storytelling, say, that they can get the help that they need to really produce some meaningful artifacts.
Right. And what are some of the projects you're currently working on that you are particularly excited about?
Yeah, so I've been obviously very busy with my job at the National Science Foundation, which is, there's some really cool things happening there. Can I tell you about any of them? Some of them are still not officially announced, but there's some things like the National Deep Inference Fabric, which is a project that we funded at Northeastern University, that is about making it easier for people to peer inside language models to get an idea of what it is that they're doing, because I think there's incredible insights to be unlocked there. So I'm really proud that I was kind of part of supporting that. We have other things exciting, maybe even possibly more exciting things on the horizon that hopefully will be announced in the next couple months. In terms of my own research, I found my book very compelling. So there's some things that I wrote about in the book that I was like, yeah, why aren't I working on that? That seems really important. So a lot of my research has kind of shifted towards this problem of how can we make it easier for people to tell machines what they want them to do. And so that means it's sort of this interesting mix between thinking about human computer interaction, which is one kind of field of computer science, and machine learning and artificial intelligence on another side, and regular old programming on the third side, and how they can all come together to make it easier for people to accurately convey tasks to machines. And so We're looking at ways of really simple interfaces for people to specify reinforcement learning tasks, because we think that, again, reinforcement learning is a really powerful way of telling computers what to do, because you don't have to tell them what to do, you have to tell them what to want. You have to tell them what they're trying to accomplish. And so if we have good tools for letting people spell out, this is what I want the computer to accomplish, and let it figure out behind the scenes how to actually make that do that most efficiently, that seems like a good partnership. And so yeah, so we're looking at ways of doing that. And I'm super interested in, as I mentioned before, this notion of when people convey tasks to each other, we use multiple modalities. We'll say something, but then we'll give an example, like for example, such and such. And if you once you start listening for it, it's really remarkable. Whenever you're talking to someone, you ask them a question, they're going to tell you the story, and then they're going to give you an example to ground it. And those two things together are kind of like the magic 1-2 punch that gives the overall shape of the solution, but also grounds it in the details, so it's not wrong. And how can we make interfaces that kind of have that structure to them, right? When we write a program, it's just the program. When we do machine learning, it's just machine learning. How do we get the strengths of both to integrate? And so we're looking at some so far very very basic ways of doing that. But yeah, it looks like language models are able to take on some of those tasks, and so we're using that as a starting place.
I see. And how do you approach teaching complex AI concepts to students who are relatively new to the field of AI?
I mean, before ChatGPT, I was teaching classes. I haven't taught anything since then. Um, when I was teaching, what I would do is I would try to ground these ideas in concrete examples that people can wrap their heads around. And so I taught a introduction to computer science class for non-computer scientists, and there's always be a section on machine learning and artificial intelligence and what that means and how it connects to these other concepts. I don't know how I would do it now, though. It's such a different world now. And so there's some really great classes. I heard about a class at the University of Texas, Austin, that my colleague Peter Stone's been teaching that sounds like a one stab at kind of figuring out what is it that people need to know and how can we get it across to them. But this is something that I'm excited to be heading back to academia and grappling with exactly that question.
Right. And what do you think is the next big breakthrough we should expect in reinforcement learning field?
Oh, wow. The next big breakthrough that we can expect in the reinforcement learning field. I mean, I'm hoping that people are working on having these systems learn faster, right? So from less experience. This has been a long-standing challenge in the field of reinforcement learning. Is that if you look to see the learning curves, like how much experience does a system need before it starts to behave well, we're talking about millions, tens of millions of interactions with the world. And the fact that it learns it all is very cool and extremely exciting, but the fact that it learns that slowly really limits the utility of these kinds of systems, because they don't, it's rarely the case in the real world that you can spend 70 years of experience letting the system figure out what to do before you then deploy it. So yeah, what can we be doing, almost like a foundation model sort of perspective, so that a minimal amount of additional experience is needed before a task can kind of get locked in and the system can start to perform well in that task. That's certainly what I would love to see.
So, what impact do you hope your research will have on society in the long term?
So I like to think that I'm trying to put out a message of empowerment, that people have the ability to get computers to do what they want for themselves. I think the last decade or so of people all across different walks of life interacting with computers has actually been fairly disempowering for them, that they feel like big companies control the way that the computers are going to interact with us, and it's really about extracting our data and extracting value from us, and not about empowering us. And so to the extent, what I'm trying to do is put ideas out there that make it more possible for people to be empowered and not disempowered.
And how do you feel about the portrayal of AI in popular media?
It's easy for people to write stories where AI is the bad guy, and I get that, and there's a lot of them out there. The more people feel uncertain and unconfident, the more that that we need AI to be our fictional bad guy. Um, so I don't know. It feels almost orthogonal to what's actually happening. I think it's people kind of working through their fears, and that's reasonable. I'm not going to complain about that. Um, I think I mean, you have to keep in mind well, okay, I need to keep in mind that a lot of people don't go to college, but of the people going to college, a growing fraction have been studying computer science. So of college, in terms of college educated people that are out there in the world, the fraction of that group that is computer literate, not just computer literate, but like actually trained in computing, is getting larger and larger and larger and larger. And I think that's going to shift the kinds of stories that people can tell, both uh, in the world of fiction, but also in terms of popular press. Like the people writing articles can assume a bit more understanding, a bit more foundation in terms of computing. And I think that's going to be really helpful, because then ultimately we're going to get news stories where, okay, well, you understand this. Here's the new piece that's on top of that. And that's going to allow it to be much more less hype driven, more grounded, more accurate, and hopefully more informative.
Right. And what kind of policy changes would you like to see to better regulate and support AI development?
So as a person who's currently at the National Science Foundation, we're not allowed to sound off on policy issues. That's like a different branch of the government. Um, but I I personally am very heartened by the fact that there's so much conversation around this, because I think that more important than any one particular policy is the notion that people need to have a voice in setting those policies and kind of determining what they're comfortable with in the society that we're living in. And I've been excited to see how many, once upon a time it was just AI people, like just computer scientists having these conversations, and now there's lawyers involved, there's philosophers involved, there's ethicists involved, there's people involved who are impacted, and the fact that we're having these conversations and trying to figure out, well, what's okay and what's not okay, that's exactly what we should be doing, and I'm really happy.
Right. And the final question. So, if you could give one piece of advice to young researchers in the field of AI, what would it be?
It's gotten very complicated. So if they're AI research is such a big community now, and it's so diverse, and it's so much, such a big fraction of it are people who are new to it, and so whatever kind of past culture there was is kind of getting overwritten with this new culture. So it's hard to know, but in general, the strategy has always got to be, find the way to make your contribution. Like, what is it that you care about, that you think matters, that you have the tools to actually help move forward, and do it, right? Do it. Like, don't just think about it, don't just talk about it, but do it. That's the field tends to respect that, and other researchers tend to respect that. And so, yeah, find your niche and make a contribution there. It's very easy to be disheartened because the big AI labs have a lot more resources, and they're doing big splashy things, and it doesn't have to be big and splashy. In fact, I think one of the things that we're missing right now are the little small ideas that make things make sense. And so ask yourself, like, how are you helping with that, right? How are you helping to shed light on something that other people are puzzled by? And if you can help make those kinds of contributions, and lots of us are doing it, that's going to really move us forward.
Professor Littman, thank you for this wonderful conversation and for your time. I really appreciate it.
Oh, my pleasure. I hope we get to meet in person sometime soon. We don't live that far apart.
You're right. Thanks so much once again.